Hello everyone, my name is Nida Harman Magiri. Welcome to my YouTube channel. Today we are going to learn a very important topic from compiler design, which is operator precedence passing. What is operator precedence passing? Let's see slide by slide the introduction to to all the advantages, disadvantages, how it is going to be worked in compiler design. So let's go with the video. Let's get started. First, the introduction. What's the introduction means? Operation precedence passing. Introduction of operator precedence passing is a bottom-up passing technique. It is used for passing expression with operators of different precedence, commonly applied in compiler for parsing arithmetic expression. Here, it is a particularly useful for parsing expressions that involve operation with different precedent level like plus, into, minus, the operations, the arithmetic operation basically. Commonly used in compiler to handle arithmetic or logical expressions, and than it's simpler than other parsing technique like LR or LL for certain grammar types. Basic concept of terminal parsing. Here, the non-terminal, this represents group or pattern in the grammar like E for expression. Operator precedent passing table, a key structure that defines how operators relate to each other in terms of precedent. A is less than B, which means A has lower precedent than B. A equals to B means A and B have same precedence. A is greater than B means A has higher precedence than B. Let's go with the next slide. This is slide number 4. Operator precedent relation. Here, the first point, which is operator precedent relation. There are three relations between terminal symbols, where A is less than B, I yield precedent to B, which means shift operator means here if the A is smaller than B, then you have to shift the operator. If the another statement we have, if A is equals to B, A has equal precedence with B, which means reduce the operation. Which means often used around parentheses. Here, parentheses are basically used for growing the operations. And the third expression, which means A is greater than B. Here, A takes precedence over B, which basically A is greater than B. Here, we have to reduce the operation. These three symbols helps decide when to shift or reduce the passing. The fourth one is rules for operator precedent passing. Here, to use operator precedent passing, the grammar must satisfy specific rules. No null production allowed. The grammar cannot include rules that produce an empty string. Second one, no two adjacent non-terminals. Here, this ensure clarity in how operators and operands interact. And the last, grammar must be operator precedent grammar. Here must be an operator precedent grammar, a set of context-free grammar suitable for precedent passing. My next slide is to be present passing steps with sample. Here, the example of passing steps is here the given, if we see the given grammar, E gives E plus E, E into E, and parenthesis E, here the functional E. and ID. The step 1 to convert to operator precedent grammar. There is no left recursion. We modify the grammar. Here, the modification of grammar is E gives E plus E into E. And the second step is create operator precedent table. Here, removal of left recursion to make it suitable for precedent parsing. Let's see for the table. Operator precedent table. Example you have here. The plus, here you can see the plus operator is first into parenthesis and then ID. The only operators has been determined in table. There is no any non-terminal is present in the table. So here you can see by having this first step by applying left recursion to the grammar, then there is the modification in the grammar, and then we compare the both grammar and create the table. So plus, which is greater than plus. Basically here, in first step, the plus is greater than the another plus. If you see, definitely the into the asterisk, which is always greater than plus and minus. However, this table has been completed through these two equations, and it's more required for the step 2. Here, the construct on operator precedent table based on terminal and their precedence. So here a matrix that show how each terminal relate to two other. For example, plus has lower precedence than into, so plus always been lesser than into. ID typically has no precedent over ID but may yield precedent to operators. Especially symbols like dollar include the beginning and the end of the inputs. Here you can see the dollars are present in the input in the last column of the table, also the row of the table. So it's mean that there is no any, there is including, there is a input of dollar will be present for table. My next slide is parsing example. Here you can see ID plus ID into ID. What you have to do is in stack the first, as we have discussed it already, that the first input will be the dollar, then the ID and plus ID then ID. If you're going with the left recursion, then go through that. So the first one will be changed, will be left recursion. From the left hand side, the recursion will be changed. Here you can see in stack the first dollar has been done goes in input ID plus ID into ID dollar. Then you have to shift ID. In third step, reduce ID to E because the ID has having the precedence of into. So this into is greater than plus. So you have to reduce it to E. Shift plus then ID. The fifth step is reduce ID to E, then reduce E plus E to E. Step number 6, which is apply reduction into E plus E. E into E gives E. Then E plus E gives input is accepted when reduced to 1E and stack contains start and end symbols. That is E into E to E. which is a non-general. Then it's accepted by the stack. Let's go with that. I hope you are clear with parsing example. Let's go with the next slide, which is the advantages of operator parsing. First, simple and efficient for arithmetic expression, useful for expression with well-designed precedent, easy to implement. There is no general purpose, can be parsed all context-free grammar. No support. The requirements is backtracking, decision making, and straightforward using the table. Definitely, if you get the table, you can understand the operator precedence parsing. Let's go for the limitations. No suitable for all types of grammar. Grammar must not have null productions. Not capable to handle ambiguous grammar. No general purpose can be parsed. All context-free grammar. No support for null production empty string. Ambiguous grammar. Only work if grammar is written in a form suitable for operator precedence. Let's go with the application. Used in compiler design to evaluate expression during parsing. Common in expression evaluator, interpreter, and calculator. Often used in the expressions parsing phase before syntax directly transmitted. I hope you will clear with the application. Let's go with a summary of this topic. Operator precedence parsing is a bottom-up technique tailored for expressions. Used a precedent table and rules to guide parsing. Strike a balance between simplicity and power, especially for arithmetic-heavy language. This is basically used to balance the arithmetic expressions in language. Thank you so much, guys. If you like this video, comment down if you have any doubt. I'll show you answer your question. So thank you for watching my video. Thank you guys. Bye.